There. Okay, so let me change to the board. There we go. All right. Question number 5. People have asked me to solve this question. All right. So the question is, please find the turning points and the coordinates of those turning points for the equation, the function x factor of 27 minus x squared. All right. So we need to find the turning points. Remember, turning points are the points in the function where the derivative is 0, right? So if we have something like this, I'm going to do a quick drawing here. Something like this. We would have exactly 2 turning points. We would have this one over here and this one over there. This turning point is a maximum, and this one over here is a minimum. All right. Now, these turning points, since they are points, they have coordinates x comma y, and this one will have also coordinates x comma y. Right. It is our job to find the coordinates of those 2 points and also to tell the person if those two turning points are maximums or minimums. All right. Now there is one really simple way of doing this, and that is just graph this in the calculator. So I'm gonna do that right now using GeoGebra. Let me show you how. It's like this. All right, so the equation was x factor of 27 minus x squared, right? Beautiful. So the function should be something like this. Now, I'm sure we can see it. I'm sure about it. So what we can do is just zoom out a little bit to kind of see what the function is. Look at that. It's a little bit better, Rob. It's a little bit better now, right? Function is a little bit better now. So what we are looking for are these 2 points. We have a minimum point over here, which we know the answers. Look at that. Negative 3, negative 54, and a maximum of 3,54. Like this, like graphing the function and looking for minimum and maximum, we can see the values. This, you can do it in the calculator, all right? But let's assume if this was an exam, the instruction, the keyword would be show the process, right? You need to show. If you need to show, you need to do every single step in the piece of paper, right? And they use the calculator just for quick calculations like multiplications and those sort of things. So this process, this by graphing in the calculator and looking for minimum and maximum point is not gonna be good, right? We need to know how to find those 2 turning points and how to tell if they are maximum or minimum by using the board, right? So I'm gonna change into just the board, and I'm going to show you how that is done. There. All right. So we know there is a maximum and we know there is a minimum. But let's assume for a minute you didn't see that graph, right? We didn't see that graph, and we need to find the amount of minimum, maximum points and tell if they are minimums or maximum, right? So the first step will be to reorganize my function in a way so that I can work with it, so that I can derivate it, find the derivative, right? So what I'm going to do is just do the distributive property here, right? I'm going to distribute this x because we have a multiplication, right? So we should have 27x minus x cubed. Look at that, x cubed. There we go, right? Now, in order for me to find the turning points, what I need to do is to find the points for which the derivative of this function equals 0, right? Because those are the turning points. So to find the derivative, I'm going to do y prime. We can use this way of writing. We can use this notation, right? And y prime, the derivative of y will be 27 minus 3x squared, right? Like this, I just found the derivative of my main function. Look at this. Pay attention, please, to the notation. Over here, I have y, and over here, I have y prime. This is the main function, only that I distributed the x, and over here, I already found the derivative, right? Now, from here, I want to find the points so that the derivative is equal to 0. So I want to do y prime equal to 0, the derivative, right? That means replace y prime by 0. So the function will be 0 equals 27, the equation, sorry, minus 3x squared. If I solve this function, this equation, for x, if I solve x in this function, I will find the points for which the derivative is equal to 0, right? You can solve this again using the calculator, right? Or you can just isolate for x. I'm going to do that here real quick. If I pass the 27 to subtract, so I'm going to have 27 negative, right, equals to negative 3x squared, right? The negative 3, which is multiplying, I can divide to this side. Negative 27 over negative 3, this will be equal to x squared again, right? This value, negative 27 over negative 3, is positive 9, right? And this is x squared, which means that we have two solutions for x, right? By doing the square root on both sides, we can cancel the square on the x, right? But the square root of 9, some people will say it is 3. Well, it is not only 3. It is also negative 3. So we have two possibilities, positive or negative 3. Remember, the square root of a value, the square root of a number, is both positive and negative, right? So there we go. We have the coordinates for x for which the values were, for which the derivatives were 0, right? Let me pass real quick to the GeoGebra. There, look at that. Remember our function? In our function, we have 2 points for which the derivative is 0. We have this one over here and this one over there. And both have coordinates in x of negative 3 and positive 3. So for now, we know those values. We know the coordinates of x as of now, right? Change again into the board. All right. So we know in our function, if I were to draw a Cartesian plane here, we know in negative 3 and in positive 3, in these two values, there is going to be a maximum or a minimum. I don't know where, but anywhere in this negative 3, anywhere in this line, and also anywhere in this line over here, right? I don't know where. I don't know the coordinate of y. I know the coordinates of x, negative 3 and positive 3. They could be positive or they could be negative. We don't know about that, right? To find those, all I have to do is replace the value of my coordinate in x into the main function, any of these two. These are the main functions. So we know the coordinates of x, and if we replace them in the main function, the solution will give us the coordinate for y. So I'm going to write it here. All right, so we want to find the coordinate of y. We know the coordinate of x, right? Negative 3 and positive 3. We want to find the coordinate in y. I'm just going to replace the values in the main question, in the main function. So y equals 27 times x. I'm going to do it first with positive 3 to find the coordinate of the positive 3 value. And then we will do it with negative 3 to find the coordinate of the negative 3 value, right? This is negative 3. Maybe you can see it. This is negative 3, and this is positive 3, right? Okay, so I'm going to replace the x by positive 3 minus 3 cubed, right? And by using the calculator, again, in an examination, it is okay to use the calculator for these types types of multiplications and subtractions and all of these, we know this should be 50. What was that? 54, right? So we know this should be 54. All right, beautiful. So we have the first solution, the first coordinate in our 2 points. We know there are two turning points. Turning points, right? We know there are 2 turning points. One of them is -3 comma something, and the other is +3, +3 comma something, right? Now we know the coordinate of y for the 3. This is 3 comma 54. We know there is a turning point in 3 comma 54. So over here, let's say in exactly this point over here at 54. In exactly this point over there, there is a turning point. All right. Now we don't know if that turning point turns out to be a maximum or a minimum. We don't know that. We will find it in a minute, all right? But we know there is a turning point there. Now, this was for the value of +3. Remember, there are 2 turning points, and we just found the y-coordinate of the +3. We need to find the y-coordinate of the -3 as well. So we need to do this process again, but with -3. All right, by doing it real quick, I have y equals 27 times -3 minus -3 cube. For those of you who are doing this with the calculator, don't forget about the parentheses. The parentheses here is extremely important because you are doing this with the -3. The exponent also applies to the -3. All right? If we do this with the calculator, we will have a value of, let me see, -54. All right, so we have -54. All right, so the 2 turning points are going to be 3 comma 54 and -3 comma -54. Beautiful. That means that around here at -54, there is another turning point, another one. Now, if you are following this graph, you kind of see that if you were to join the points, if you were to join them, you would have something like this, right? I know that this line has to come down at this point. It cannot continue going up because this point is a turning point. That is the definition of turning. It turns. It was going up and then it goes down. It is a turning point, right? So I know from here, this is a maximum. From this graph, this is a maximum point. I know that from the graph again. But also in this one, since this is a turning point, this have to go up. It was going down, the line was going down, and then it has to go up, right? So this is a minimum point. From here, we know the 2 turning points, and 3 comma 54, here's this one, has to be a maximum. Remember, so far we know there are 2 turning points, and we know the coordinates, but we didn't know which one was a maximum, which one was a minimum. We didn't know that. But now from the graph, we know the 3 comma 54 is a maximum, and -3 comma 54, which is this one over here, comma -54, is a minimum, right? Now, there is another way. There is another way besides having to sketch this graph. There is another way for you to tell which of these maximums and minimums points, which of these turning points are maximums or minimums. There is another way, and that is called the second derivative criteria or test. You don't find this in the book, guys. So what I'm about to show you right now is something that you cannot see in the books. I'm going to pass to Spanish because I feel like since it is new, I might lose you here. All right. ¿Qué es eso del criterio de la segunda derivada? ¿Qué es? Bueno, el criterio de la segunda derivada, mira, la primera derivada me ayuda a encontrar turning points, pero la segunda derivada me ayuda a encontrar máximos o mínimos. ¿Cuáles de esos turning points son máximos y cuáles de esos turning points son mínimos? ¿Qué quiero decir con el criterio de la segunda derivada? Pues lo primero que vamos a arrancar es con derivar una segunda vez. Aquí encontré y', hice la derivada, la primera. Aquí vamos a hacer y2', esta de acá. Y' y luego prima otra vez. Y2', la segunda derivada. ¿Qué significa tomar la función, derivarla y luego volverla a derivar? En otras palabras, la derivada de la derivada. Y2', la derivada de la derivada. El test de la segunda derivada, ¿listo? Entonces, para hallar y2' no es más sino derivar mi derivada. La derivada de 27 es 0, entonces no la voy a poner. Y la derivada de negativo 3x al cuadrado es negativo 6x. Con la segunda derivada ya terminada, solo voy a reemplazar los valores de x. Recuerden que esto es x, y esto también es x, y. Si reemplazo los valores de negativo 3 y 3 en la segunda derivada, voy a obtener un valor para la segunda derivada. Y luego voy a mirar mi criterio. Ponle cuidado al criterio. Si, a ver, second derivative test. Second derivative test, right? Second derivative test, y2 prime. If y2 prime is lower than 0, which means negative, then we have a maximum. And if y2 prime is bigger than 0, which means positive, then we have a minimum. Ponerlo aquí. Positive. No alcancé a escribir más. Aquí. Negative. Bueno, no alcancé a escribir más. Entonces, vamos a cambiar los valores de x en nuestra segunda derivada y vamos a mirar el valor de la segunda derivada. La segunda derivada, si cambio x por negativo 3 menos 6 por negativo 3, la segunda derivada es positivo 18, ¿cierto? Nos dio positivo 18. Positivo. Positivo, mira, la segunda derivada es mayor que 18, es positivo. ¿Qué pasaba cuando la segunda derivada era mayor que 18? Ay, aquí me puse mal, aquí es negativo y positivo. Las puse al revés. Menor que 0 es un número negativo, negativo. Y aquí mayor que 0 es un número positivo. Ahí está. Eso. Entonces, mira, 18 es un número positivo mayor que 0. La segunda derivada es un número positivo, es mayor que 0, un número positivo. Entonces tenemos un mínimo. Entonces en el punto negativo 3 hay un mínimo. Criterio de la segunda derivada y sin necesidad de graficar. Volvamos a hacerlo con el siguiente número. Aquí lo hice para negativo 3, que era nuestro primer turning point. Para y2', evaluada en el punto negativo 6 por 3, evaluada en el punto 3, o sea, el segundo turning point. La solución, y2' sería negativo 18. Mira, 6 por 3, 18 y el negativo te dio negativo. Entonces, cuando reemplazas y2', x, por positivo 3, la solución es negativo 18. Nos dio un número negativo. Negativo. Entonces, negativo 18 es menor que 0, es un número negativo. En ese caso tenemos un máximo. Y como no, para 3,54 hay un máximo, máximo y mínimo. De nuevo, criterio de la segunda derivada para encontrar máximos y mínimos sin necesidad de graficar. ¿Puedes hacerlo graficando? Por supuesto. pero no tienes que. Puedes verificar la segunda derivada, que mira que la primera función era horrible, la segunda función fue más facilita, que fue al cuadrado, y la tercera función es una cosa lineal. Cada vez que derivas vas haciendo la función un poquitín más fácil. Entonces, reemplazar en la segunda derivada, por lo general, es mucho más fácil. Eso tiene el beneficio de la segunda derivada, que cambiar los valores es mucho más fácil y analizar si máximos o mínimos es inmediato mirando los valores. Listo, recordemos. Si la segunda derivada es menor que cero, o sea, un número negativo, hay un máximo. Si la segunda derivada es mayor que cero, o sea, un número positivo, entonces hay un mínimo. All right, guys. Hopefully this was helpful for you. If you have any more doubts, let me know. Thank you.